On page 348. All right. And you're doing, see the triangle problem? I would suggest that you make a sketch. I wouldn't suggest that you do a big fancy graph because that's going to take up time. That's not productive. The sketch is really all you need. So I'm going to put the 3 coordinates. T is -2, 1. And then R is 4, 3.
What is R?
4, 3. It's in your book, right? Page 348. And then M is -4, -1. So check my plotting as I do this to make sure I don't make careless mistakes before we even get started. So -2, +1, 4, 3, -4, -1, and we're finding the circumcenter of this triangle. So there's the triangle. You can sketch it in. The sketch, what it does is it allows you to kind of organize your thoughts. I need to find the midpoint of 2 of the sides, and then the equation of 2 of the sides, so I can find the perpendicular bisector equations of 2 of the sides. I don't need the 3rd side. I could do it, but hopefully with 2 sides and being careful, I won't make a mistake. So if I want to find the midpoint, that's the easiest thing. So I'll do that first. I'm going to find the midpoint of TR by averaging the x's. So -2 + 4 divided by 2, and averaging the y's. 1 + 3 divided by 2. So that's 2 over 2, which is 1, and that's 2. You guys agree with that?
Wait, wouldn't that be 0 though? Because between
Negative.
No, sorry, it's 1.
Wait, what did you just do?
I'm finding the midpoint. Average the x's.
Oh, you add them in. Okay.
Add, divide by 2. So the midpoint should be 1, 2, and that's should be right here. Do you see what I did? Okay. Now I need to find the midpoint of a 2nd side. So I'll do the midpoint of,
You should do T.
I was going to do RM. I can do TM.
Where'd you get
So
that?
midpoint of TM. So I use little subscripts to keep my work organized so I know what line I'm looking at. So -4 + 2, not enough room now, let's try that again. Midpoint of TM,
So the center's gonna be outside of the circle.
-4, yes, because it's obtuse, the circumcenter is going to be outside the circle. Plus -2 divided by 2, and -1 + 1 divided by 2. So that's a good idea because it lands on the axes. So -3, 0. So my picture's a little off because it's a sketch, but that's the midpoint of TM. So far, so good. Now I need the equation of each line, so I'm going to find the equation of this line. Okay, so I'm going to find the equation for TR. So I can do y = mx + b or point slope form. Point slope form is pretty easy because the slope is not hard to find. So slope is rise over run. So 3 - 1. Difference of the y's divided by the difference of the x's, 4 minus the -2, which is 2, 6, or a third.
Wait. What is the -4? 4 minus -2? 4?
Because it's slope.
-1.
So remember, slope is y minus y sub 1.
Oh yeah, okay. And then y, and then x minus x sub 1. Wait, what? Okay.
So the slope of this line, I'll repeat that. Let me just write it down. I'm writing this so I know where they all go. So slope is the difference of the y's. So y minus y in the numerator over x minus x. Okay?
Oh, so the things that you did in green were finding the
Midpoints were green.
Okay.
Coordinates, vertices were red, slopes are gonna be black. Okay? So now I'm gonna find, I'm gonna continue.
To get the midpoint of MR.
You want me to get the slope next, or finish that line equation?
Well, so it's gonna be 3 over 1. For t.
Negative 3 over. No, but yes, but I have to find Tm. So let's stick with the yellow line. Okay, I'm gonna make the line equation. Y. Did you guys like the y equals mx plus b way? It was easy? Okay, so let's stick with that. Y equals 1/3 x plus b. So pick a point. Which point? I need to use a point. Does it matter which point?
Don't you need to do the midpoint?
No, I could use I could use T, the midpoint, or R. I have to make this. Oh, you're right. I don't really need that line equation. I'm going to make the equation for the perpendicular. Right. So I need to use the midpoint. So it's going to be roughly like this, right?
3 over 1, right?
So I have to.
Or negative 3 over 1.
So I have to use the perpendicular slope, and I was actually making a yellow line equation, but I don't need it.
Isn't it
So negative 3
over 1?
over 1, which is negative 3.
Wait, where's
So I'm finding the equation, you guys, of this pink line here. So this is going to be pink line, and so it's going to be the equation of the perpendicular bisector. Does that make sense?
So the y
The pink one. I'm going to do the pink one.
The one that's not on drawing.
Because, Cal, I need 2 perpendicular bisectors to intersect to find the centroid. The only thing I needed from the yellow was the slope.
You said centroid.
Circumcenter. So I'm going to put in the point 1, 2. Are you there, Cal? You with us? Okay, so 2 equals negative 3 times 1 plus b. So 2 equals negative 3 plus b. So add 3 to both sides. B equals 5. So the equation of that pink line is y equals negative 3x plus 5. Let's look and see if it looks reasonable. If I extended that pink line, does it look like it would go through 5? Yeah, right? Just like that. Roughly, right? It's a sketch. So just to keep things straight here, this is the equation of the pink line. I need one more perpendicular bisector before I can solve a system.
Wait, where'd you get the negative 3?
Because the slope of the yellow line's 1/3. So the slope of the pink line is opposite in sign, so negative, and reciprocal, negative 3 over 1. Which is just negative 3.
How did you get the slope of the yellow line?
With the slope formula. And I'm sorry I erased it.
Now don't
No, I didn't. It's right here. Slope.
It's so x or y 3 minus y
3 minus 1 over 4
Slope
minus
formula is y2 minus y1 over x2 minus x1. Okay, so now we have to do the whole thing again for this green line here. Okay, we got to find the midpoint. We did. Now we're going to put in a perpendicular, right? So we want the perpendicular to this green line, which would look
Wait, did we find the
something like that, right?
The first one.
Isn't this?
We have to find the slope of the green line now.
Isn't it just 1?
Well, let's check and see, right?
Which one's y?
So now we're finding the slope of Tm,
It's 1 over.
right? Because 1 minus a negative 1 over negative 2 minus a negative 4, the numerator is 2, and the denominator is 2, so the slope is 1. See where they're getting that? That's of this green line here. So what's the slope of the perpendicular line?
-1.
This is slope of -1. Now we need an equation for that line.
So it would be y equals -1x plus, or no, it would be.
Y equals -1x plus b. You're right.
Replace it with the midpoint.
You have to replace it with the
Y and
midpoint.
x.
So we have to make it go through 0 equals -1 times x, which is -3 plus b. 0 equals 3 plus b. So b equals -3. So the equation is y equals what? -1x. And then look at the picture and see if it makes sense.
Yeah, it makes sense.
So that's the light blue line. That's this one. That equation should go with that line here. This one. So we have two lines. Now we have to find where they intersect. So now you have to solve a system with the pink line and the blue line.
So when you solve a system, that's what you get. The
Hold on, let's try that again.
But that's how you get their exact intersection.
The intersection
Unless it's on there.
is that. So solve the system. I would use elimination. I think it's easy. I would just multiply all of this. Oh, I mean, I would multiply this by -3. To eliminate the x variable. So my first equation stays the same. I know, this is hard. This becomes negative. Oh, you know what? This might be better with substitution. Solving the system. Because I could just plug this in for y. Wouldn't that be easier?
Yeah.
So -1x minus 3 equals -3x plus 5. So add 3 over. And 3x and add 3. So 2x
Plus, or
equals
equals 8.
8.
Divide
X equals 4. Go back to the picture and make sure it looks reasonable. So will these intersect at 4? It looks a little off,
No, I think it.
but my sketch is just a sketch, right?
Yeah. And
So,
also your lines.
right, that's what I'm saying. These lines appear like they're gonna cross. You know, first of all, this line doesn't look very perpendicular.
No.
So if I made it more perpendicular looking,
Yeah.
would that be any different?
Yeah, it's around 4.
Yeah, so it looks like it's still reasonable. Not perfect, but it's a sketch. It's in the right quadrant. That's how come you use a sketch. You want to make sure you're not getting something like in the upper left quadrant. Okay. So I have X. No, this is one for you.
You only have to sketch.
We have to ask me a question again?
So you're saying this is only a sketch?
No, I'm saying like I'm using a sketch because if I don't have a sketch, you wouldn't know what I was doing, right?
Yeah. So.
I mean,
so
You could do it without a sketch.
you could do it without a sketch. I don't suggest, for me, I couldn't. Personally, me, I need a sketch. But for me to be a teacher and not use a sketch, you would be so overwhelmed by right now because you wouldn't even know where any of the numbers went.
So you don't have to go back or keep this and then make a whole other one that's perfect.
No. The sketch is just to help you organize your work. Like, look at all the different, this is like Algebra 1, one whole 2 months of Algebra 1, and then some geometry added in.
This is.
I'm not finished though because I still have to find y. Miranda.
Why do you only need 2 of them?
Good question. Because the third one should land in the same place. So just for sanity purposes, at this point I would just do 2 and look it up. Look your answer up. To check your own work, if you didn't have an answer key, you would have to do the third one.
So now we plug this into the y, right?
Yeah, so guys, we haven't finished, right? We have to plug it into y,
Negative 7
and y should be negative.
equals negative.
So I'm going to take my first equation and say y equals negative 3 times my x value of 4 plus 5. Y equals negative 12 plus 5. Y equals negative 7. So going back to my picture here, you know, again, let's see how reasonable it is. It's not terrible. Well, it's not bad. I mean, that's arguably
And so it would be,
negative 4, negative 7.
so it would be 4 negative 7.
Yeah, it's
4, negative 7 is the circumcenter.
How many problems are in our homework?
So,
Well, they're on the board.
so every single problem on the homework.
Okay.